Good afternoon. I am Debbie Hersman, Chairman of the National Transportation Safety Board, and I'm joined today by Dr. Joseph Cawley, who's the Director of our Office of Research and Engineering, and Mr. John DeLisi, who's the Director of our Office of Aviation Safety. We're here today to provide you an update on our investigation into the Boeing 787 JAL event at Boston's Logan Airport. The expectation in aviation is to never experience a fire on board an aircraft. In 2 weeks' time, we saw 2 cases of battery failures on the 787 and the grounding of the entire fleet by the FAA. The significance of these events cannot be understated. This is why the NTSB has been working since January 7th to determine what happened and why. Today I can tell you what we know so far. We know that the lithium-ion battery experienced a thermal runaway. We know that there were short circuits, and we know that there was a fire. The work that we continue to do will tell us why these things happened. And it is answering the why question that will ensure that the appropriate corrective actions are taken. I'd like to begin by showing you a presentation about what we have found. First, we'll go through the timeline. At about 10 o'clock, the aircraft arrived at the gate from Narita. 183 passengers and a number of crew members deplaned. Within about a half an hour, the cleaning and maintenance crew arrived, and they noticed the smoke in the cabin. At 10:35, a mechanic noted flames coming from the APU battery in the aft electronics bay. At 10:37, airport rescue and firefighting were notified. At 10:40, they arrived on scene. And at 12:15, they reported that the fire was controlled. I'm going to talk to you a little bit about APU batteries, and particularly the ones that we've examined since the event. The battery that you see here that's damaged is the one that we have been working on in the lab. The other battery is the battery from that same aircraft from the main battery location. Once we removed the battery from the aft electronics bay, this is what the aft electronics bay looked like. You can see damage to surrounding structures and components in the bay, and it was confined to an area immediately near the APU battery rack, within about 20 inches of the rack. In the photo on the right, that you'll see adjacent to the APU battery were the wing anti-ice controllers on the left and the battery charger on the right. These batteries are manufactured by GS Yuasa Furtalis, who's the electrical installation integrator, and they are unique to the Boeing 787. The same battery is used for the primary airplane battery and for the battery that's used for the APU. The main battery is the final power source should all other electrical generation fail. This slide is going to give you a sense of our investigative activities that are occurring all around the world. We've done a number of examinations of different component parts and are participating in groups in different locations. The battery charger unit and start power unit have been functionally tested. There was one minor finding with each unit, but given the damage experienced in this event, that is not unusual. So we're trying to still determine the significance of those findings. 2 general purpose modules are being downloaded in Seattle today. We are looking to retrieve maintenance messages and records from non-volatile memory. The battery monitoring unit had extensive damage, which prevented functional testing. Individual circuit checks and detailed examinations have been performed, and investigators continue to validate their findings. There are additional activities that are being conducted by Boeing and in which the FAA is participating in Seattle and other locations. The NTSB is participating in many of those activities. We are evaluating potential scenarios with the systems, failure modes. We're gathering factual information to support and rebut different scenarios. We're also reviewing manufacturing records for potential issues or trends. And we are gathering information that was collected in recent supplier audits. So there's a tremendous amount of work going on all around the world. We actually have 2 shifts of employees, both here and in Japan, who really are working around the clock to try to solve this. We're going to talk a little bit more about the batteries, the individual batteries that we've been looking at. The photo on the left, this is an Exemplar battery, and it shows the 8 interconnected cells that make up the battery. The photo on the right, and you can see the cells that are outlined in red, show the 8 damaged cells of our battery that we're investigating in the lab. This chart shows the battery specifications as provided by the manufacturer. This is a 3.7 volt battery, and it can operate in a range from 2.5 volts to 4.025 volts. We're going to go drill down a little bit more into the cell of the battery. So this is one of the 8 cells. Now if you look inside that cell, you'll see that each cell has 3 foil windings. Each of those 3 foil windings are 33 feet long, about 33 feet long, and that makes up approximately 100 feet of windings per cell. So let's talk about how these cells are made up. There are 3 sets of windings, which you see in the middle of the schematic. And if you envision very, very thin, continuous sheets of both aluminum and copper laid together, folded and rolled over, and then flattened out like a sandwich, you can see those 3 sandwiches of thin rolls that make up the electrodes. Let's talk about the electrode construction. So here's a cross-section of the electrode that makes up the winding. So of note, you've got 2 electrodes that are sandwiched between 2 separators. The first electrode is a copper strip coated in graphite. The second electrode is aluminum, and it's coated in lithium cobalt dioxide. Now we're going to look at what some of our examinations have entailed. Radiographic examinations of the incident battery and Exemplar batteries have taken place in an independent test facility here in the Washington area. The digital radiographs, or the computed tomography scans, or CT scans, generated from these examinations have allowed our team to document the condition of the battery, the internal condition of the battery, prior to disassembling it. And this is important because we don't want to damage the battery as we're taking it apart. We're going to be taking you, some of you, to the NTSB lab in a little while for a pool opportunity, and you're going to get to see our investigators at work. This is our lab, and we continue to examine the electrodes visually. We're photo documenting them. We're using a scanning electron microscope, and we're also using energy dispersive spectroscopy, or EDS, to analyze the elemental constituents of the electrodes. We're looking for contaminants or defects. So you see in this photo, you see two separate windings laid out on the table. That is some of the activity that you're going to see upstairs. It won't be the same winding. We've moved on, but you'll see some windings laid out. Let's talk about the examinations that we've conducted to date. So in this graphic, you'll see overhead that we've done a scan of the entire battery. So we've done CT scans of the entire assembly. And you'll see cells 1 through 8 are numbered, and we've done examinations of each of those cells. Cells 5, 6, and 7 are of particular interest to our investigators because they appear to have experienced the most thermal damage. So you can see that there are a number of different examinations and evaluations that have been conducted on those 3 cells. So what are we looking for when we're examining these cells? We're looking for signs of thermal runaway. Thermal runaway is an uncontrolled chemical reaction between electrolyte and electrode that occurs at high temperatures and is uncontrollable. Short circuits. Short circuits are unintended current paths between electrodes. And finally, we're looking for manufacturing defects. Those could be things like foreign material or material defects. In summation, our investigators are really looking for anything that's unusual, might give them an indication of what happened in this battery. So let's talk about some of our findings so far. We have found some short circuits. Here is an example of a short circuit on cell 5. This photo shows melted anode current collectors on the cell. This is indicative of high current damage from a short circuit. And this CT scan of the entire battery shows the entire battery assembly viewed up through the bottom of the battery. It shows 8 cells. And what you're looking for on this CT scan is noticing the bulging and the deformation of those 8 cells. So here are our findings to date. Fire was present. There are signs of thermal runaway and of short circuiting. We have a number of next steps. We are early in our investigation. We have a lot of activities to undertake. We're going to be completing those lab exams that we talked about with that incident battery and documenting all of those. Then we're going to be looking at Exemplar batteries to do some testing and some further evaluation of those batteries. Finally, we're working to synthesize all of the work that's being done in our lab with the work that's being done all around the country and all around the world, looking at those component parts, looking at the airworthiness, at the certification, at the design standards, at the testing of the components, and feeding all of that information back and making those connections as we evaluate the safety of the systems, particularly the systems that are integral to the battery. There are a number of parties to our investigation. The NTSB uses a party system to gain technical expertise and assist our team in the work that they are doing. The Federal Aviation and Boeing are parties to our investigation. And through international agreements, through the International Civil Aviation Organization, particularly Annex 13, those agreements allow for foreign participation in accident investigations. The country where the accident occurs is the lead. The event that occurred in Boston involved a Boeing aircraft operated by Japan Airlines, and it had component parts that were manufactured in other countries. We have accredited representatives from Japan, from the JTSB, our counterpart agency, and they are assisted by technical representatives from JAL and GS Yuasa, that is the battery manufacturer, Our French counterparts, the BEA, are an accredited rep to our investigation, and their technical advisor is Thales. We also have a number of experts that are available to help us. One of the groups that we've taken advantage of is actually from the Naval Surface Warfare Center's Carter Rock Division. They have worked on lithium-ion batteries since the late 1970s, and their assistance has been invaluable to our investigators in the lab as we work to identify and understand the failure that occurred in this battery. We may also appoint additional parties to the investigation, and we may receive assistance from other groups as the investigation moves forward. We know that there was another event just about a week after the event that occurred at Logan. The JTSB, our counterpart agency in Japan, is leading that investigation. On January 16th, at about 30,000 feet, as they were climbing, the crew noted smoke and fumes in the cabin and on the flight deck. They received various alerts regarding the main battery. They diverted to Takamatsu Airport, and upon landing, ATC reported smoke around the forward part of the aircraft. They conducted an emergency evacuation, and we've certainly been communicating very closely with our counterparts in the JTSB, and again, they are supporting our investigation as an accredited rep, and we have investigators in Japan supporting their investigation into the ANA event as an accredited rep. We've had 2 battery events in 2 weeks. We're working very hard to determine what happened and why it happened. We're going to be completing examinations into failure scenarios and coordinating with our colleagues around the world to understand what happened. We have to understand why this battery resulted in a fire when there were so many protections that were to be designed in to the system. We will be continuing to provide additional information and availability to you as the investigation proceeds. These findings that we provided to you are not determining the cause of the event. It's just sharing with you some characteristics that we've identified so far. There is a lot more work to be done before we can identify what caused this event, what initiated it, but we'll be working to do that. We're happy to take questions. Yes?
Would you be comfortable with the planes flying again tomorrow or next week, based on the little you know so far?
The question is, would we be comfortable with the planes flying again with the information that we know so far? It's very important to understand that the NTSB and the FAA have different roles. The Federal Aviation Administration is charged with certifying the aircraft and determining the safety of flight. They made the decision to ground the aircraft. They will make the decision to allow the aircraft to continue to fly in the future. The NTSB gets involved when there is an event, when there is an incident, when there is an accident, and we are the investigators. We are conducting a forensic investigation to understand what happens. We will be sharing the information that we know with the FAA. We are working very closely with them so that they have the best information to assess risks and make the decisions that they need to make. Tom.
Madam Chairman, can you give us a sense of how long you think your investigation might take? In other words, we're not asking when will it be allowed to fly, but how long will your investigation take? And also, you know, it's been 34 years since the FAA grounded an aircraft. Can you talk to the severity of this, of your concerns with regard to that?
Sure. There are 2 questions. One, how long will our investigation take? It is really very hard to tell at this point how long the investigation will take. What I can tell you is that we have all hands on deck. We are working as hard as we can to identify what the failure mode is here and what corrective actions need to be taken. The second question was about the significance of the grounding of this fleet and that it hasn't been done in decades. Absolutely, this is an unprecedented event. We are very concerned. As I mentioned in the beginning, we do not expect to see fire events onboard aircraft. This is a very serious air safety concern. The FAA has taken very serious action, and we are all responding to try to address what happened, why it happened, and to make sure that the aircraft that fly are safe. Matt?
Madam Chairwoman, you previously said Sunday, I think, that the voltage of the batteries was not exceeded, and that information came from the flight recorder. You described various other places where data might have been captured. Is there any place that describes whether perhaps the batteries were charged too fast, although they never exceeded the target voltage, or is there any other battery management type data available either from the flight recorder or other systems on the airplane?
The question that Matt asked is, how do we get information about the charging and the voltage on the battery, and where does that come from? Is there any other information that we have about that aside from the information that's recorded on the FDR, flight data recorder? Those are things that we are looking at right now. We do have some traces on the FDR regarding the battery. However, we need to make sure that we can validate those, that we know what's being measured, where it's being measured, and we are also looking for other sources. I mentioned that we're looking at some other downloads. We're looking at other non-volatile memory. We need to understand how that is being measured, where those traces are coming from, and their reliability. We do not have any data from the FDR that shows an exceedance of 32 volts. Yes, ma'am.
What do we know already about the causes of thermal runaway and short circuits on this type of battery? And do we know enough to know whether the two battery incidents might share a common cause?
Okay, 2 questions again. You all help me out. I have to be able to remember all of these questions. The first question that you had is, what do we know about the causes of the short circuit and the thermal runaway? What we have shared with you today is characteristics that we have identified. What we have not told you is what caused this. We are looking at this evidence, and we have to determine whether it's cause or effect. We are seeing symptoms. And so if you think about looking at this, we know that there's something wrong here. These things, the short circuit, the fire, the thermal runaway, these are all symptoms that something's wrong. Understanding why we're seeing those symptoms and how they're related and what came first and what triggered the next thing, that's information that we have yet to identify. We are working on that, and that is part of our ongoing investigation, not just with the damaged battery, but also understanding exemplar batteries and how the design is supposed to work.
Chairman, can you get the phone?
Sure. You had a second question.
Right, about whether there might be a common cause between the two.
Okay. The question was, is there a common cause between the 2 battery events that we've seen, the JAL Boston event and the ANA Takamatsu event? We are working very closely with our counterparts at the JTSB. We are sharing information. Our event occurred on the 7th. Theirs occurred on the 16th. We have a little bit of lead time ahead of them, and so we are further along in our investigation just because of that time. Once we have the opportunity to see what they are finding through their work, through their scans, we are very much looking forward to being able to compare and collaborate on whether or not we're seeing similarities or differences in the batteries as we're doing those teardowns. And I'm going to take some calls from the phone. Maybe if the operator can queue those up.
Thank you. If you'd like to ask a question, please signal by pressing *1. That is *1 if you'd like to ask a question.
Go back. And we'll take a question over here.
Do you have any reaction to, there have been some reports and people have been quoted that some senior people inside Boeing think this is an overreaction, the grounding is an overreaction. Do you have any reaction to that?
The question is, there are reports that people within Boeing think that the grounding is an overreaction. The NTSB's job is to investigate events. It is the FAA's job to determine whether or not aircraft are safe to fly. We respect the FAA's decision. They have used information that they have to make that decision. That is a very difficult decision, but I will tell you, we do not expect to see events like what we saw on the 787 with the battery system. This aircraft has been in the air for less than 100 hours, and to see 2 battery events within 2 weeks in the early flights of this aircraft is not what we would expect. Can we take a call from the phone? A question?
Yes, call, your line is open.
Hello, Dominic at Seattle Times. Can you tell us, is it correct to infer from the fact that the battery didn't exceed its voltage, its design voltage, that it didn't overcharge, or does it suggest that it didn't overcharge? And secondly, there's another report that you're discounting.
How about we take one question at a time?
Okay.
Your first question was, do we know from the information that we have that the battery didn't overcharge? Is that correct?
Correct.
What we have is information from the FDR. Those FDR traces indicate that the battery voltage did not exceed the 32 volt, and that's actually 32.2 design limit. But what we are still trying to corroborate is where those traces came from, how that information is corroborated, at what point those measurements were taken. We continue to do that work, and we continue to work with Boeing to identify those recording mechanisms. Second question?
Is that suggestive of it didn't overcharge?
We do not have any data that shows that the battery was overcharged.
Or not? I mean, you don't know either way?
We do not have any data. The data traces that we have from the FDR do not show that the battery overcharged beyond the 32.2 limit.
If I could ask a second question, there was a report today that you were discounting the possibility of internal defects in the battery. Is that so?
The question is our investigation discounting the any internal defects in the battery? That is exactly why we are tearing this battery down, is to identify whether or not there are any internal defects. As I mentioned, we have done CT scans. We've also used the scanning electron microscope and EDS to look at these batteries. We still have some more work to do. You'll see our team working there today. We are reporting to you on the information that we have gained so far. We still continue to do work to assess all of these batteries. And if I could ask each of you just one question, please, so everybody gets a chance. Alan.
Thank you. Can you describe in any greater detail the damage that you saw in the Crystal Bay? For example, within that 20-inch area, were there any electrical components or systems that were damaged, and what kind of structure damage was there as well?
The question is, can we describe the damage in the E&E bay where the APU battery was? Our investigative team that was on scene described structural and also component damage around the APU battery within a radius of about 20 inches. The APU battery was spewing molten electrolyte, very hot material, around the APU battery. We did also see some damage that was involved with the extrication of the battery as well. The firefighting response teams did try to take the battery out before NTSB investigators arrived, so we were examining the scene after the battery had been removed. Yes?
Is there anything from what you've seen so far that would suggest whether the problem is limited to the battery or whether it might involve other components such as the charger?
The question is whether or not we've narrowed down whether the problems are associated with the battery or any other component parts. That is still a very open question for us. We have not yet ruled anything out. We are evaluating everything. We did provide to you some early characteristics and evidence that we identified on the battery having to do with thermal runaway and short circuits. We still have to figure out why those events occurred and what initiated them. Let's take another call from the phone.
We'll go next to.
Hi, Jason Parr with Wired Magazine. To revisit the overcharging issue, is there information from the batteries that indicates monitoring of each individual cell that you're able to access, or is it the battery as a whole? And related to that, is it possible possible that a single individual cell could be overcharged, but the overall battery would still show a nominal voltage?
Everybody can hear that, right? The question from the phone was whether or not the battery and the information that was monitored regarding the battery overcharging was measuring each of the 8 cells, was measuring the entire battery, and whether or not an individual cell could overcharge, and that might affect the battery operation. Jason, those are very good questions. Those are some questions that our investigative team is asking right now, and that is what we are trying to work out as far as what's recorded, how it's recorded, and what information do we have, not just about the battery, but about the component parts of the battery.
You've said at least twice now that, in a pretty stern voice, we don't expect to have 2 fires on a new airplane that just started. So my question is, will your investigation show if something was certified that should not have been certified, or if this was just something that no one could have foreseen? I mean, will there be blame in the end if somebody goofed?
The question is, have we identified any issues with respect to certification, and are we looking at the certification process? And I just do want to make sure that we're clear. We had a fire event in the Boston Logan event involving JAL. The JTSB has identified a smoke event with the ANA aircraft in Takamatsu. And so just to caution you, as far as the reporting on 2 events, these are 2 battery events, but the Japanese event has not yet been called a fire event, okay? So the question about certification, we have a team that is looking at system safety. They are looking at fault tree analysis and at certification standards. One, they are looking at, were those certification standards adhered to? And then the question of, were they appropriate? We will be working very closely with a number of groups, including the FAA and Boeing, as we collect that information and evaluate the analysis and the risk assessments that were done. What we have seen with these 2 events do not comport with any of the risk analysis that we would expect to see with respect to reliability or a smoke or fire event in these batteries.
What does that mean?
These events should not happen. As far as design of the aircraft, there are multiple systems to protect against a battery event like this. Those systems did not work as intended. We need to understand why. Yes, sir.
If you could tell us what could cause a thermal runaway. And just to clarify the previous answer you mentioned, can we understand it that you have not ruled out an individual cell being overcharged?
That was 2 questions.
Sorry.
Okay, so the question was what would cause a thermal runaway? And I think on that, I'm going to defer to Dr. Colley and let him answer that question. And your second question was?
Just to clarify that you have not ruled out the possibility of an overcharge on a single battery.
The question was, have we ruled out an overcharge on a single cell, one of the 8 cells that make up the battery? We have not yet ruled anything out. We are still evaluating all of the scenarios, potential failure scenarios, and we will be looking at the different batteries and comparing them with the Exemplar battery. Let me turn the podium over to Dr. Colley to talk about what might cause a thermal runaway.
A couple of examples would be a short circuit within the cell itself could ultimately result in a thermal runaway of that cell. Another possibility could be collateral damage from a neighboring cell that had experienced a short circuit or an overheat, and then the conduction of heat from one cell to another just cascades down the row of neighboring cells.
Yes, sir.
Yes, Madam Chairwoman, you spoke of multiple systems designed to protect against a battery event like this. What are some of those systems?
The question is referencing multiple systems designed to protect against a battery event. and what are examples of some of those systems. First, we would definitely expect that the battery is being monitored and that there are appropriate mitigation efforts to protect against any failures that would include things like thermal runaway or short circuiting, to be able to disconnect the battery, to be able to shut it down safely, to make sure that that information is known and understood before it gets to a critical point. We are looking at any of the mitigation measures that were designed, one, into the battery to protect against a failure, but also into the system. The battery is a part of a bigger system. There's an integration with other component parts, and we need to make sure that the interaction of those parts was also protected and that there weren't outside forces acting on this event that created or precipitated something.
Do you have any reason to think that there may have been such outside forces, that the problem may come from a foreign element to the
The question was, do we have any indication of any other parts of the system that might have affected the battery and the battery failure? Those are exactly the kinds of things that we're looking at. As I mentioned, we haven't ruled anything out. Our investigations are very thorough, so we are going to look at every potential scenario that could have resulted in this situation developing. I'm going to take another question from the phone. I know we've got scores of people on the phone.
Thank you. We'll go next to... Hi, it's Chris Van Cleve at WJLA here in D.C. Could you talk to us just sort of about, I know you don't have an answer to how long this investigation will take, but when you talk about testing Exemplar batteries after you finish testing the batteries involved in this one event, are we talking days to do those tests? Are we talking weeks? Is there sort of a broad ballpark to help us sort of gauge what kind of progress or how long this thorough investigation will take?
Chris has asked a question about what other testing we might be doing to Exemplar batteries to try to understand this and how long it will take. You know, this is a very interesting technology. It's novel. There's a lot of work that's being done in other government agencies, and we are actually working with a number of them. We have engaged in conversations with Carderock, Naval Weapons Systems, and also reached out to other partners at DOT as well as NASA. We are looking for other expertise to assist us, but there are tests, like a drawdown test of a battery of this size, that to go through that test, it takes a week. And so there are a number of activities that we have planned. We are going to continue to move forward with those as expeditiously as possible, but this is not something that we're expecting will be solved overnight. There is a lot of technical work and a lot of complex work to understand. That being said, if we have a breakthrough and we find something that immediately points to a cause, we will get that out as soon as possible. But I think we are prepared to do the methodical, diligent work that needs to be done to really get to the root cause of this. Another question from the phone.
Thank you. We'll go next to...
Chairman Hersman, I'm wondering if, in light of your looking at the certification, the potential certification issues, you will also be looking to other aircraft that use lithium-ion batteries and whether they need to have a review.
The question is, as we're looking at the certification process, will we also be looking at other aircraft that have been certified and are using lithium-ion batteries if any issues turn up? Our investigation will certainly be looking at the certification process as part of the work that we are doing. We want to make sure that the risks were well understood and that they were addressed. If we find that there are any vulnerabilities, we will make recommendations. And in the past, our recommendations have sometimes been focused on a particular aircraft type, but in other investigations where we find a systemic issue, they can be more widely distributed, not just in the United States, but also around the world if we think there is a safety of flight issue. Yes?
Chairman, you talked about working with other jurisdictions, obviously in Japan, and other investigators looking into the ANA incident as well. Could you talk more about some commonalities? Are these batteries from the same batch? Have you found that there is a sudden drop in voltage in this case as well?
The question is as we're working through these issues where the JTSB and the NTSB are both investigating a battery event. Have we identified any commonalities? The question specifically asked if the batteries were from the same batch or if they both experienced sudden drops in voltage. We are looking at all of that information. Certainly, we're looking to compare the FDR information from both events, and we are also looking at the battery manufacturer. We are asking some of those questions. I do expect that we will have more information to share with all of you as the investigation proceeds, and those are very likely some of the pieces of information that will come out in the coming days. Thank you for that question.
Point of clarification, we have thermal runaway that you've identified, and you've identified shorts within the battery. Do we know anything about the sequence? Do we know if the shorts were present before the thermal runaway, or do we just not know?
The question is, did the shorts come first or the thermal runaways come first? And this is exactly the cause and effect evaluation that we are trying to identify right now. We do not have we have not yet identified the sequence of events that initiated the short circuit or the thermal runaway. What we do know is that they are present, that we can document those, and that is factual information. What we are working to do is really establish why those events occurred and what the sequence was. Thank you all so much. We will be providing additional information in the coming days, and Kelly will tell you how we'll get that out. Thank you.